Okay, our last lesson for chapter 3. Okay, so today we're going to talk about word problems. Okay, so we're going to put the exponential in solving word problems. There's many different formulas. There's actually 4 different formulas that we use for exponential equations and exponential problems. And these 4 equations are following. So y equals a, actually I'm going to use these letters because I have them on the board. So a equals a naught 1 plus I to the power of n, a equals a naught 1 minus I to the power of n. Now, these letters, the A and the A0, they can be different. Okay, you can call them Y and X. You can call them Y and A0. You can call them A and P. Okay, so they can be different. What you need to understand is always, when you have an equation like this, this is your final amount. No matter what the letter is, you can call it volume. No matter what the letter is, it's your final amount. And this number that's multiplied by 1 minus I to the power of n, for example, that is your initial amount. Okay? Again, I can call it A equals P 1 minus I to the power of n. P is still my initial amount. A is my final. Okay? Now, why do I have 2 different equations? What's the difference between the 2? Look at them. Tell me what's the difference. One positive, one negative. Right? The positive represents the growth. Okay? So if whatever I'm finding, let's say I'm just going to give you an example of money because the money makes sense. Okay? So let's say I put some money in the bank. Right? I put $1,000 in the bank. And I'm earning percentage on that money. Am I gaining money or am I losing money? I'm gaining that percentage, right? So because I'm gaining that percentage, I use this formula because it's 1 plus the interest rate. Okay? If I'm losing money, so let's say when you buy a car, right? You start with you spent $20,000 on the car, right? After a year, you're gonna lose the money, right? You're gonna lose a certain percent. After a second year, you're gonna lose another percent, right? So this is when we use the minus because we're losing, and we call that the decay. Okay? So this is called the growth. So anytime your money is growing, right? You use this formula. And anytime you are decaying, you use the minus. Okay? You use this. Now, as I said, the letters will change, right? It doesn't matter what the letter is, as long as you put them in the right order. Now, I is the interest rate, right? So let's say 5%, 2%, 2.5%. But I don't put it as a percentage. I have to change it to a decimal first, so I have to divide it by 100 and put it in. N is the amount of years. So how many years are you putting that money in? Okay? So these are your growth and decay formula. And we have 2 other formulas. We're going to talk more about these other 2 formulas at the bottom of this page. Okay? Now, with exponential relations, they're modeled by this form. So y equals a b to the power of x. Now I just want to can you guys stop for a second? So if I write this, right? If you want to compare these two, this is the same as this, right? This is going to be the same as this. Okay? Now your base, if you actually do 1 plus 0.05, you're going to get this. Right? So that's going to be your base. Right? It's not going to show you as 1 plus 0.05. It's going to show it to you as 1.05. Okay? But basically 1 plus I is the same thing as B. Right? Because after you actually simplify the 1 plus I, it's going to be just a single number. And your x is your x. Okay? So yes, you might see it differently, but at the same time it means the same thing. Right? Your base that has the exponent is the same as your 1 plus I. Your exponent, if it's n or x, is still the same thing. A is the same as A0. Y is the same as A, whatever. As long as you have them in the right order. So A is your initial amount. Same as what I said earlier. I called it A with a 0. That means it's your initial. Now, B, which is your base, is your growth or decay factor. Growth or decay. It could be either or. In this case, it's growth. Now, your base. If you have a growth, right, like this, is your base greater than 1 or less than 1? Greater than 1, right? So if B is greater than 1, if your base is greater than 1, then you have a growth equation. Now what happens if I had a decay equation and I have this, and then 1 minus, let's say, 0.05. What am I going to get? What's 1 minus 0.05?
95.
So it's 0.9.
0.96, yeah.
0.9.
Yeah.
Is the B less than 1? Yes. So anytime you have a decay, because you're subtracting an interest rate, you're going to get a number that's less than 1. Okay? So if your base is less than 1, then you have a decay. So you always have to look at the base and decide, is it a growth? It will be a growth if it's greater than 1. Will it be a decay? It will be a decay if it's less than 1. Now, let's look at this example. So a city's population can be modeled by the equation P equals 1.4 bracket 1.0415 to the power of T, where P represents a population in millions T years after 1985. This is very important. T years after 1985. So when you are plugging in numbers for T, what are you plugging? So what would that be?
I have to calculate from 85 to until now.
That's right. So what would 1985 represent? What number?
The beginning.
Which is what? The year 1985, what year would it be with respect to T? With respect to T?
I have here the
How about 1988, 1986? What would that be?
1 year.
Year 1.
Zero, like zero, the beginning.
That's right.
And this is not
I need the number
Zero,
is
yes.
0. So 1985 would be number 0 for T. 1986 would be 1. 1987 would be 2. So when you're plugging your numbers, 0, 1, 2, 3, you need to know what 0 represents, what 1 represents, what 2 represents. Okay? Okay. The question is asking you, in which year did the population first exceed 3 million people? So what am I solving for? No, read the question. In which year will the population exceed $3 million?
I have to make to put P the number, and I will find the equation. I will find T.
Okay, that's right. So you put, what do you put for P?
3 million.
3 million.
Yeah.
So you're going to have to put 3 million for P, and you're solving for T. That's what the question is asking you for. Okay? Now, before we start the question, let's define a few things. So, what's my beginning population? What am I starting with? No, I'm asking you for the population. 1.4 what? Million. Right? Because how would I know that it's million? Because it tells me that P represents the population in millions. Okay? What do I want to solve for? What's my ending population that I'm looking for? 3 million. Now, question to you. Is it a growth or a decrease?
Growth.
Because?
1.6.
More than. It's growing from 1.4 to 3 million.
Okay, but how do you know if my question was not what would the population? What's bigger than 1? 1.0415. That's my B. My B is 1.0415. So it's greater than 1. Okay? This is how I know it's a growth, not a decrease. Good. Now, what would be my growing rate? So growing rate, anytime the question is asking you for a rate, it's asking you for a percentage. Okay? So it's asking for I. How would I find I? I just want to find I.
Let it be the subject of the formula. Let I be the subject of the formula.
Like what, sorry?
Let I be the subject of the formula.
So what does that mean? Like what am I'm looking for I. If you go back to the
1.585.
no.
Maybe like equation, the same.
What? Yes.
Yeah?
Yes.
For that too.
Guys, why are you thinking too hard? I'm looking for this. I know that these two equal to 1.0415. I just want I. What do? Subtract 1. That's all what I need to do. Right? Because 1.0415 is equal to 1 plus I. Right? Because this is your growth. Do you guys understand that?
Hello?
No, it doesn't look like it. Let's go back here. This is this, is the 1 plus I in my equation. So I know that this is 1.0415 is equal to 1 plus I. I'm looking for I. The question is asking you to solve for I. So all what you have to do is you're subtracting 1. Now, the interest rate has to be in percentage. So if I multiply this by 100, I get 4.15%. Okay, so I have outlined my question. I know what I want to solve for. Solve for t, 1 piece 3 moles. Okay? So all what I have to do is I plug in 3 for p. And I'm solving for t. Okay? So all what I did is I plugged in 3 for p. Now, I want to solve for t, so I want to try to isolate for it. First thing, I want to get rid of that 1.4, so I divide by 1.4. What's 3 divided by 1.4? 2.143. Yeah? Okay. Now the question is, how do I solve for t? How do I solve for an exponent?
I have a question, maybe I find the same base.
That would be doable if your numbers are whole numbers, and if you can actually go to the same base. But in this case, I don't have them. Any other ideas? You can't square root, no, because you don't know what your exponent is. Yeah. I'm dividing by 1.4 because this is multiplication. I want to bring it over, it becomes a division. 3 divided by 1.4 is 2.4. Okay. The only way that you can solve this, there is other ways, but one of the ways that you guys need to know is trial and error. Okay? So you have to plug in numbers for t, so you can find that answer. Okay? So you're going to do trial and error. So you're going to try this. If you start with small numbers, you're going to find that it's not, like if you try 2, 3, 4, 5, these are very small numbers. It's not going to change. Let's start with this. I'm going to give you a few numbers and you guys are going to plug that in. So let's try with t equals to 10. What do I get when I have t equals 10? 1.5? 1.5 is still different than 2.14. Okay? So let's try t equals 20. What do you get when you have t equals 20? You get 2.255? So, I plugged in 10. It was too low because the answer I want is 2.143. Plugged in 20. My answer was 2.255. It's too high. Give me another option. 50.
1.8.
1.8. So that's still too low, but I'm getting close, right? So give me another number.
17 maybe.
Okay? What do you get when you have 17?
1.9, 18.
So it's still too low? Is it 1.9, 18 or 1.9? You left?
1.99 is 1, 2, almost.
So 1.99?
Yeah.
Okay.
18.
If you plug in 18, what do you get?
18 is 2.07.
Okay, that's still too low, right? Because I'm looking for 2.1.
19.
What do you get when you have 19?
2.165.
Oh, we are almost.
So 19 is too high, 18
18
is too low. So it's between the year of 18 and 19,
18.5.
right? We don't go that deep, okay? So we're just gonna say this is too low, this is too high, okay? And then we're gonna say
Okay, 18.5, I got 2.121.
that's pretty close. So
75. 75. 10,
I don't know.
10, 75.
We don't have to be exact because we're doing guess and check.
Yeah, 75, it's right, it's, yeah, 75, the exact amount.
Yeah.
1075.
18.75.
Yeah.
Yeah, but we're not, as I said, like when you get something like this, it's in between. You just have to stay between 18 and 19. Okay?
So if we got same amount, what we put the amount? If you got same amount.
If you got exactly the same answer,
Exactly, same answer.
if you get the same answer, then you put that answer. Yeah. So the population reaches 3 million between year 18 and 19. So what year would that be?
From 85 plus 10.
Plus
What,
18?
18, yeah, plus 18.
So from 1980,
From 85 plus.
85. So between the year 2003 and 2004, this is when my population will reach 3 million people,
So this one is 1985 plus 1,
plus 15, plus 18, sorry.
plus 18. That's what I'm confused. Let me go.